Good morning. So let us solve these homework problems. There are only three problems. Some of you have actually done that. I have already distributed the homework to you, and then I have also published a new one. So I send the code to the SchoolSoft, so you can start working on them. But this time there are six problems, okay? Not three. These are just three problems. Okay, so let us just start doing them one by one. So which one is the longest interval on which this function that you see here is strictly increasing? Okay, they are asking you to find the longest interval. Okay, so hopefully you know how to solve the problem. What we are supposed to do, the derivative should be positive or at least zero. Okay, so that is the whole point. So if I want to solve this problem, the function that is given to me is f of x equals to minus 2x cubed plus 6x squared and then plus 18x, and then I have plus 2. So the derivative should be greater than or equal to 0 for having a strictly increasing function. So what do? You just differentiate the function. Very simple. You differentiate the function. What is the derivative? Is minus 6x squared and then plus 12x and then plus 18. Okay. So I want to put this greater than or equal to 0. This is a very standard problem, but because in Swedish system we do not study quadratic inequalities in a systematic way, then we have to be a little bit careful and find it in a different way. Probably using a diagram would be better. Okay, so the derivative becomes greater than or equal to 0, then it means that this function, this expression should be non-negative. And then, of course, if I want to solve it, it is better because I see that every number is divisible by 6 or even minus 6. So let me divide everything by minus 6. It becomes simpler. But be careful, when you divide by a negative number, you have to flip the sign of inequality. So this becomes what? X squared. This becomes minus 2x. This becomes minus 3, but less than or equal to 0. So this is the question. This is, I told you that in Swedish system, I don't know, for some reason, we do not study quadratic inequalities in a systematic way, which is very weird. But the only way that you can do it is to analyze the problem graphically. So I will follow that rule for you. The first thing, if you want to know an expression, when an expression is negative or when an expression is positive, it is a very good idea to know when the expression is 0. Because if you know when it is 0, of course, if you go a little bit to one side, it becomes positive or negative. And if you go a little bit to the other side, it becomes positive or negative. So understanding when this expression is 0 is very helpful. By the way, you can immediately understand it from graphs. I will do it for you. So the first question I ask myself is when this becomes 0. It is very simple. So for example, you can use PQ formula, you can factorize it, or anyway, let us use PQ formula. Minus P over 2 is 1, plus or minus the square root of 1. This number to power 2 minus Q, but Q is minus, so it becomes plus. So it becomes 1 plus or minus 2. Square root of 4 is 2, so I get two answers. One answer is 1 plus 2, 3. One answer is 1 minus 2 minus 1. So these are, in Swedish you say nollställe, or the zeros of the quadratic polynomial. So if you remember something from Ma3c, this is 1 0 of your polynomial, let us say it's here, and this is another 0, 1, 2, 3, another 0 here. So you know that the graph of your function, the graph of this function should pass through these 2 points. This is one thing. Another thing, I don't know how much you remember from Ma3c, you know the name of the graph of a quadratic equation is a parabola. And we have two parabolas, two types of parabolas, opening up or opening down. Yes, it is Ma3c lesson. Do you remember when it opens up and when it opens down? Okay, so if this coefficient is positive, it opens. So if I have a function like this, so if A is positive, it opens up. and if A is negative, it opens down. This is, I'm using Ma3c knowledge, but if you have forgotten that, take it for granted, okay? So if I have a parabola of this type, and I consider this A, if that A is positive, this is the type of parabola you will have, and if it is negative, this is the type of parabola you will have. So in my case, A is what? 1, and 1 is positive, so it should open up. So it should open up on the one hand, on the other hand, it should pass through these 2 points. I don't want to draw a good picture just in a scratch paper. You need to convince yourself that this is the graph, something like this. You don't need to be precise at all. Because my goal is something else. My goal is to do what? I want to know when this expression is negative. Negative means below the x-axis. Because this expression is my y. I want to have y negative. So it means the y coordinate should be negative. So, which branch of the graph is acceptable? This branch of the graph is acceptable. Okay? So this is when this is negative. But I want to answer it in x. In which interval this is happening? Between here and there. So, for being below the x-axis, x should be somewhere between -1, at most 3. Yes? And this is the longest one. I want you to see why they have emphasized on the word longest, because this one is also true. Do you see that? Why? Because if the function is increasing from -1 to 3, of course it will also be increasing between, for example, 0 and 2. Yes, if your function is increasing between -1 and 3, definitely this will also be increasing on this interval as well, because this interval, if, for example, let us imagine like this, if this is -1 and this is 3, and let us say that my function between these two limits is increasing, this is 3. For example, it means that my function is going up here between these two limits. If the function is going up between these two limits, it is clear between these two limits from 0 to 2 is still going up. Is that right? So if they haven't mentioned the word longest, then this question was ill-designed, because there will be more than one options correct. But now they have mentioned the longest one. The longest one will be this answer. Yes, we cannot have longer than that. Why? Because if I go a little bit to the right, even a little bit, this branch will go to the positive part. And if I go a little bit to the left, the branch will go to the positive one. And if that is positive, this will violate what I want. So this is the maximum length of the interval for which this graph is increasing. Is that right? Yes. Yes, please.
How could it be true that in between 0 and 2 it is strictly increasing, when at the point 0 the graph is clearly sloped downward?
No, there is nothing you can say at the 0. Yes, because I have told you several times this one. Please take it now forever. Increasing, decreasing is not a local behavior. If you want to see if a function is increasing or decreasing, I cannot ask you, is the function increasing at this point? How can you answer that? You can answer, is the slope positive or negative at this point? This is a sensible question. But if I ask you, is this function increasing at this point, it is meaningless, because to see the increasing, decreasing behavior, you have to have at least an interval, or you have to have at least 2 points to compare what is happening here and there compared to one another. So if I want, saying that the function is increasing at one single point or decreasing at one single point, it does not make sense at all. So increasing, decreasing is a behavior that you have to compare the behavior of the function here and somewhere else to see if it is increased or decreased. But you can talk about if the derivative is positive at one point or negative at one point, because the derivative at one point is interpreted as the slope of the tangent line. and you can draw the tangent line there. That tangent line either has zero slope, or negative slope, or positive slope. Okay, but you cannot ask if the function is increasing at one point. Yes, do you understand that? Yeah. Okay, so if you want, we can also draw the graph using GeoGebra to see how it works. So what might be, it would be a better idea. So how can I draw this using GeoGebra? Y equals to minus 2x cubed. And then I have plus 6x squared. Yes, and then I have plus 18x. And then I have plus 2. Yes, this is the function. Let me make it a little bit smaller. This is the function which is, oh, very, very, so let me make it a little bit more beautiful. Yes. Okay, might be, so if I want to see it between 1 and 3, so let me draw these lines. X equals to minus 1, that is one line. And the other one, x equals to what? What was that? Was 3, yes? And I draw that. So this means that in print, technically speaking, you have to only consider this part of the graph. And do you see that the function is increasing between these two vertical lines? But if I go a little bit to the right, it starts going backward, okay, going down. And if I go a little bit to the left, it is still decreasing. So this is the longest one. But you can immediately see that from 0 to 2, if I draw this 0 and 2 again, okay, and x equals to 2, now between these two new lines, still the function is increasing. Oh, sorry, between these two lines, between 0 and 2. The function is still increasing, but that is not the longest interval on which the function is increasing. Yes, please.
If I compare the points 2,
Mhm.
3,
Mhm.
will the graph still, will the interval still, because it is strictly increasing?
Yeah. Yeah, it is, because I understand what is your concern. Your concern is what is happening up there. But your impression is that because up there the tangent is horizontal, so it is 0, so the function is not strictly increasing. That's what I'm saying. If you want to see a function is strictly increasing at that point, this is even meaningless question. You understand why? Because you have to compare the behavior of the function up there and the behavior of function another point to see between these 2 points what is happening. Yes? Okay. Okay, so let us now go to the next problem. What is the next problem? Number 2, this one, consider this function. The sum of all extreme maxima is equal to what? Okay, some of you were confused that what is extreme maxima. When I say maximum value or just simply maximum, what I am referring to, I told you in the lesson. Because you can have local extreme points. Point means x and y coordinates together. But if they are talking about the maximum value, or just simply maximum, or minimum value, or just simply minimum, they are referring to the y coordinate. So what I am asking you in this problem, the sum of all extreme maxima, it means that go and find all sum of all extreme. So that was, I was a little bit careless because I have to use which word? Local. Because that was the lesson. I should have mentioned the sum of all local extreme maxima. Yes, so that was my mistake from my side, sorry. But I have to find all local extreme maxima, means the y values, and add them up. Okay? So that is very easy, so according to what we have learned so far. So what should I do? I will try to find it. In this problem, we have to pretend that we haven't studied the second derivative test, because this homework is related to that part, okay? So what we do, I want you to do it with using the first derivative test. It is a little bit lengthy, but that's the homework, so you have to access, you can have time to do it. So minus 5 over 4x squared minus 1 over 4x cubed, and then plus minus 1 over 16 x to the power of 4. So I want to find all local extreme points of this function. Okay, so what should I do? Pretend that you haven't studied the second derivative test yet. So what do? You have to differentiate this function. It becomes 5 over 2 x minus 3 quarters x to the power of 2 minus 1 quarter x to the power of 3. This is the derivative. And then you put the derivative equal to 0. So what happens? I have to put this equal to 0. So if you don't mind, let me write it from the other way around. So I would write minus 1 over 4 x cubed minus 3 over 4 x squared plus 5 over 2 x. And I put this equal to 0. For simplicity, I would get rid of the fractions by multiplying everything by minus 4 to make it simpler. So it becomes x cubed plus 3x squared. I am multiplying this by minus 4, so it minus 20 divided by 2 minus 10, x equals to 0. And then I have to solve this equation, but this is chapter 1 problem because the degree is 3. And I told you in Ma3c there is only one way that you can solve these problems, is factorization. Yes? So how can I factorize it? Factor x out. So I factor x out, it becomes x squared plus 3x minus 10 equals to 0. And then it means that either this one is 0 or that one is 0. This one is 0, the answer is found. This one is 0, I, for example, use PQ formula. Factorization is faster, but I'm not sure if you remember factorization. So let us do that. Because factorization, I need two numbers whose sum is 3 and the product is minus 10. It's extremely simple, plus 5 and minus 2. But let us pretend that you have forgotten that. I want to teach you in a way that you can use minimal knowledge, but still you will be able to solve this, okay? So this question is very important. You will get 4 or 3 points for one question in the national exam to be able to find the local extreme points. It's a very simple question. So what you will do, you will solve it using, for example, PQ formula minus P over 2 plus or minus this number to power 2, 9 over 4, minus Q. But Q itself is negative, so it becomes plus 10. If I take the common denominator, it becomes plus or minus 49 over 4. And then the square root of 49 is what? Minus 3 over 2 plus or minus 7 over 2. I will get two answers. One answer with the plus sign, 7 minus 3, 4 divided by 2. The other answer with the plus sign. No, what the minus sign, minus 10 over 2, which is minus 5. So I got three answers. In this case, if this is given in the exam later, you can use immediately the second derivative test, because the second derivative test for this one is also very simple. You just take another derivative and put the numbers there. Do you remember? Okay, let us do it later. But here, let us pretend that we haven't studied the second derivative test yet. So what should I do? I have to do it in this long way. So what should I write? I would write f here, f prime of x here, and f of x here. Sorry, that was wrong. I have to write x here. So what are the numbers? These three numbers in order. The smallest one is minus 5, the next one is 0, and the next one is what? 2. 2, yes. And then we know that the derivative here is 0, 0, 0. And then I have to calculate these numbers, which is a little bit unfortunate, but you have to do it, okay? So I have to go back and put the numbers here. So let us calculate them one by one. So f of minus 5 will happen, so I have to put minus 5 here. Be careful, because this is the f row. So you put minus 5 there, so it becomes 5 over 4 times minus 5 to the power 2, and then I have minus 1 over 4, minus 5 to the power 3, minus 1 over 16, 5 to the power, minus 5 to the power 4. Okay, so let us calculate this. So this one is 25, 125 over 4. This is also minus 125, so it becomes plus 125 over 4, because minus minus becomes plus. And this one is 625 over 16. Yes? So what is the answer? So this becomes 250 over 4 minus 625 over 16. But I have to take the same common denominator, which is 16. 4 times 1000 minus 625. What's the answer? 375 over 16. That's the number. Yes? And then for putting 0 is very simple. What is 0? Just 0. And 2 is also simple, it's not hard. So the only hard probably calculation could be this. Okay, so I put 2 there. So what happens? F of 2 is equal to 5 over 4, 2 to the power of 2, minus 1 over 4, 2 to the power of 3, minus 1 over 16, 2 to the power of 4. That's also extremely simple because 4 and 4 are cancelled. 5 is left, 8 and this is just 2, and this is just 1. So what's the answer? It's 2. So this answer is also, yes. Okay, the hard one is this positiveness and negativeness. That is a little bit unfortunate. You have to do it anyway. Okay. So what should I do? I have to go to f prime row, but be careful. F prime is a little bit simpler. And you don't have to calculate the detail, the exact number. You just need to convince yourself it is positive or negative. But that is also not very easy for this problem, okay? It's a homework problem. So you have to sit down and do it patiently. So what should I do? I replace a random number before minus 5. So what is that? Minus 6. And then I put minus 6 here. So let us do that. These are a scratch paper work if you want. So 5 over 2 multiplied by minus 6, minus 3 over 4, multiplied by minus 6 to power 2, and then minus 1 over 4 multiplied by minus 4 to power 3. So this one, let us simplify as much as we can because that is very easy. It becomes minus 15. This becomes 36 divided by 4, 9, so it becomes minus 27. And this becomes minus 64, so it becomes plus 16. So it is negative. Yes? You don't need to calculate the rest. Whenever you are convinced it is positive or negative, just write it down there. You don't have to calculate it. So a random number between these two, what is that? I will choose minus 1. Minus 1 is the simplest one. But be careful. Again, this is f prime row. I go to f prime. So I put the minus 1 there. So it becomes minus 5 over 2, the first one. The second one becomes minus 3 over 4. And the last one becomes 1 over 4. So again, it is negative, is it? Or positive? Did I do it right? Because that is a little bit strange. I don't know if this is...
You have...
So let me double check. This one, I put minus 6 there. Is it in the right equation? Yes. And between minus 5 and 0, I chose minus 1.
Sir,
Yes?
it's minus 3 divided by 4, and minus 6 to the power of 2 it gives us a positive, so it would be plus 3 divided by 4, no?
You are talking about this one. So this one is correct. This one to power 2 is positive 36.
Wait, where did you do the function?
No, this
of
one.
minus 1?
No, this is minus 1.
Yeah, I'm talking about minus
Okay,
1.
minus 1 is this one correct?
Yes.
This
It
one
should
is
be
also
plus.
correct. Yes?
It should be plus, I think.
No, why? Minus 1 to power 2 is already plus,
Okay.
and then you have a minus 1. Yes?
Right.
So it would be minus 5 over 2 minus 3 over 4 plus 1 over 4, because if I put minus 1 here, it becomes plus 1 over 4. Yes, but something is a little bit strange, I agree. But let me calculate it. Okay, so it becomes minus 5 over 2, and this one becomes minus 2 over 4, which is minus, yes?
Why did you insert minus 4? It's minus 6, and then minus 4.
Yes, yes, yes. That was the mistake. Thank you. This is minus 6. Yes, that was my mistake. Okay, so this one is correct. Minus plus 1, this is minus 1 over 2. So this is negative. So this one is negative. So Ma3c I have done something wrong here, which I did, of course. This one is correct, this one is correct, but this one to power 3 is minus So it will become positive. Why? Because 6 to the power 3 is 216 divided by 4. This is minus 42, yes, but this is 54. So yes, thank you very much. That was the mistake. This is positive. Between 0 and 2, I choose 1. Okay, so let me clean this scratch paper. If I put 1 there, what happens? I put 1 here. 1 is more or less simple because it becomes 5 over 2 minus 3 over 4 and minus 1 over 4. Positive, this becomes positive. And then I choose a number after 2, for example 3, and then it becomes 15 over 2, and then minus 27 over 4, minus 60, minus 27 over 4. It's negative. Yes. So this goes up, down, down. But I have two maximum points. One of them is this one, and one of them is this one. This one is a minimum one. Okay? Okay, but what is wanted in the problem? The sum of all local, the word local I missed, the sum of all local extreme maxima. So what does it mean? It means that at the y coordinates of maximum points. So then I have to do that. So it is 375 over 16 plus 2. 407 over 16. So that is the correct answer. Okay? But now let us do this problem using the second derivative test. You will see that in this problem, second derivative test is not extremely simple because one hard part is to find these numbers. They are still the same. We have to do them. But doing this positive or negative in this way is not needed. Let us now go to, for just extra practice, I want to go to the second derivative. Let me write it here. The second derivative test, I take another derivative, which is 5 over 2 minus 3 over 2x minus 3/4 x squared. These are my candidates. I put 0 there. F double prime of 0 becomes 5 over 2 positive. So I understand that this is minimum. Very simple. You see, so this is very faster in this way. But I need to calculate that at 2. So F double prime at 2, I put 2 here. The numbers are a little bit smaller. So this becomes 5 over 2. I multiply this by 2, it becomes minus 3, minus 3. So it becomes negative. So I understand that this is maximum. And I do it for number minus 5. I put minus 5 here, so it's 5 over 2 plus 15 over 2, and then 75 over 4. Yes? So this becomes what? 20, 10. So 10 minus 75 over 4, is it? Negative again. So this one is also maximum. So you see that this is much faster if you use the second derivative test here. Okay? But still, you have to calculate these two numbers, which is calculated here and there. Yes? So you have to calculate f of 2 and f of minus 1. So you cannot forego this one. Okay? But you could forego these calculations I made here by using the second derivative test. Okay, but I was also lucky here. I just want to refresh your memory. Why I was lucky for the second derivative test? Yes? 0. Because if I am, unfortunately, one of them turns out to be 0, then I'm not sure what to do. I have to go back to the first derivative test. But I would say that in the exam, if this is given in the exam, because at that time we have studied both of them, I would myself prefer to do it using the second derivative test. But this homework was designed for the first derivative test. Any questions? Okay, let us go to the next problem. So here, if the following figure is part of the graph of this function, you see it here, what is 2b minus 6a? So here, to be honest, I was also careless a little bit, because you need to use the information from the previous lesson to solve this. I don't know, some of you could solve it. I want to hear from you, how did you do it? Because I saw that some of the answers are correct. Okay, so I want to, yes, can you tell me? Okay, now I want to hear from you. Okay, tell me. Yes.
What I did was, I think it was almost impossible to do without the second derivative.
Yes, and that was my fault. Sorry for that. Yes. Because there is no, it could be possible if you knew this number. So it might be when I drew it, I told you that you are not allowed to actually guess this, because that's not a grid point. Might be, this one is not a grid point from this y-axis. If you had this information, you didn't need to use the terrace point. Okay, so this is my mistake, that I designed a question that you couldn't solve at that point. Yes, but now you have everything at your disposal. We delayed the homework one more, because this is related to minimum point and which point? This point, which is a terrace point. Okay, so we have to use those pieces of information, because I have two unknowns in my problem. One piece of information will not be enough to solve this problem. Okay, but now you have access to it. So what do? You would say that, okay, this point is a minimum point. The x-coordinate is completely clear. What is that number? 2. So because this is a local minimum, what does it mean? It means the slope of the tangent line at this point is 0. And we already know how to calculate the slope of the tangent line. I differentiate my function, I replace the x with this number 2, it will give me the slope. But because this is a minimum point, I know the slope should be 0. Yes? So let us do that on the board. Okay, so the function is y equals to x to the power of 4 plus ax to the power of 3 plus bx to the power of 2. We know that the derivative is very simple, 4x cubed plus 3ax squared plus 2bx. By the way, these problems are very common in national exam, but they are very simple. I mean, the algebra is extremely simple. You see the differentiation is extremely simple, and you know that y prime of 2 is supposed to be 0. Why? Because you see that the x-coordinate of the local minimum point is 2. So it means that the slope at top 2 is 0. What does this mean? It means that if you go to your derivative, replace x with 2, the answer is supposed to be 0. So I will do that. I will replace x with 2. And the answer is supposed to be 0. But this is very simple. 8 times this is 32. 4 times 3, 12. 4b equals to 0. I move this to the other side because I have to solve a system. And divide everything by 2 for simplifying things. So it becomes, I can also divide by, am I right? By 4. Yes. I divide by 4. 3a plus b is equal to minus 8. But you see that I cannot solve this for b and a because I need an extra piece of information. My intention when I was designing question back then was to tell you the y coordinate as well, which I missed that one. I think I rescaled the function later and then I missed this grid point. If I have given you access to this grid point, how could you solve the problem at that stage? Let us say that you know that this point, because I have given you this 2, you see? So this is minus 2, this is minus 4. Let us imagine this is minus 4.5 for the time being. If I did it like this, how could you solve the problem? No, can you just explain it exactly because that is extremely important. I will write them for you in a summarized way today. But let us say that this point is minus 4.5. 0.45. Okay, this is minus 0.45. And how can I solve without even looking here? Yes?
Substitution.
Where?
The derivative.
No, be careful. Because if I give you this minus 4.5, can you read the coordinates of this point? Yes, that coordinate will be 2 and minus 4.5. But that point lives where? On the curve. So it means the coordinates will satisfy the equation of the curve. So it means that those numbers should be replaced here. For x, you put 2. For y, you put, for example, minus 4.5. It will give you another equation. You will write it here, and then you solve a system of two equations in two unknowns. Is that clear? That was my intention when I was designing this question, and that is why you see that I have given a 2 here for you, so that you can understand the scale on the y-axis. But I forgot when I rescaled it using GeoGebra, this is no longer a grid point. So it's more or less useless. Is that right? But now we already know about the terrace points and inflection points. So for this week, if you solve the problem this week, you had enough information to solve this problem. How could you solve the problem now? Everyone sees that this is a terrace point. Okay, what is the x coordinate of the terrace point? 0. And the y coordinate is also 0. But do you remember we studied that every terrace point is an inflection point. And an inflection point, the second derivative is 0. So this means that the second derivative at this point should be 0, which we haven't studied back then. Okay, but anyway, now we can solve it. So I take another derivative. What happens? Take another derivative here, 12x squared plus 6ax plus 2b. But y double prime at 0 should be 0, because the second derivative at an inflection point is always 0. Be careful, this is always 0. The reason this is 0, because in this problem it is the origin. Okay? So y double prime of 0 is 0. So it means that if I go to my y double prime, replace x with 0, the answer is supposed to be 0. Let us do that. I go to my y double prime, I replace x with 0, and the answer is supposed to be 0. But this one is 0, this one is 0, so 2b becomes 0. I immediately can find b. b is 0. If b is 0, I put it here, so 3a becomes what? Minus 8. So a becomes what? Minus 8 over 3. So I found a and b. But what is the question mark? The question mark is asking you about 2b minus 6a. So it becomes 2 times 0 minus 6 times minus 8 over 3. 2 times 0 is 0, minus minus plus. This becomes 16. So the answer is 16, yes? Is that right? Okay. So that was my mistake, sorry. But in principle, we can solve. If this is given in the exam, you have to use both the idea of the terrace point and the idea of the local minimum. Any questions? Okay, so let me stop this recording here.